As you may have heard from your students, we began our unit on multiplication last week. We looked into factoring and multiples of numbers. And today we introduce divisibility rules, which can further help your students factor numbers and determine whether they're prime or composite. Let's look at the rules together. The first rule that we looked at was 2. A number is divisible by 2 when it's an even number with a 0, 2, 4, 6, or 8 in the ones place. We can look at some examples on the chart. 456. There's a 6 in the ones place. The numbers in the tens or hundreds don't determine whether a number is divisible by 2. We're just looking at the ones place, just like in this example, 832. There's a 2 in the ones place, so the number is divisible by 2. The next rule we're going to look at is 3. If the digital root can be divided by 3, the number is divisible by 3. But you may ask yourself, what is digital root? Let's look at the number 351. If we take each digit and we add it together, 3 plus 5 plus 1, we get 9. 9 is our digital root. 9 can be divided by 3 and get an even group of 3. So therefore the number is divisible by 3. The next number is 4. A number is divisible by 4 when it's an even number whose digits in the tens and ones place can be divided by 4. So the students should understand that the number would also be divisible by 2 because it's an even number. But let's look at that rule further with the example 5,324. With this rule, we're just going to isolate the two numbers in the tens and the ones place, so 24. The remaining digits don't have any determining factor in this. We can take 24 and see that when it's divided by 4, you get 6 equal groups. So therefore, this number is divisible by 4. The next rule is 5. This is a rule that children are pretty familiar with. They've been doing this since kindergarten, first grade, and so on. So this rule has a 0 or 5, a 5 or 0 in the ones place. So for the example, 55, the 5 in the tens place is negligible. And then the example 10. I gave a non-example here, 537, to just reinforce that the number in any other place does not determine whether it's divisible by 5. Let's look at 6. 6 is one of my favorite rules because you should have already done the hard work for you when you determine whether it was divisible by 2 or 3. So 6 is an even number that is divisible by 2 and 3. So once again, because it's even, it has to be divisible by 2. But further, it also has to be divisible by 3. The reason this works is because 2 and 3 are factors of 6. So let's look at an example. We have 24 here. 24 is divisible by 2 and 3. So therefore, the number is divisible by 6. We determined that it was divisible by 2 by looking in the ones place and seeing that it has an even digit, and that it's divisible by 3 by adding the digits together to get 6. 6 can be divided by 3, so this number is divisible by 2 and 3, making it divisible by 6. Then we have the number 9. 9 is related to the divisibility rule of 3, because 3 is a factor of 9. So the rules are very similar. If the digital root can be divided by 9, it is divisible by 9. Let's look at some examples here. 324. Some students might assume because it's even, it's not divisible by 9. But if we look at the digital root and add the digits together, we get 9. 9 can be divided by 9, so it's divisible by 9. Now let's look at another example that sometimes challenges kids. 729. If I add those digits together, I get 18. Since 18 can be divided by 9 into 2 equal groups, this number is divisible by 9. The final rule is something they definitely learned all the way back in kindergarten, 10. If you walk by a kindergarten classroom, you'll hear them counting by tens. An even number with a 0 in the ones place. 700 has a 0 in the ones place, so 700 is divisible by 10.